Hello, good morning. Today we are starting chapter 7 and we have networking concepts. Now, because this is a professional program, Cisco finds it imperative to introduce students to networking concepts if they want to discuss the maintenance of computer networks. And as you know, these are basic networking principles that we have discussed in our previous classes, especially in your first year when I met you and took you in Intro to Networking and Telecoms. And today, we'll take the opportunity to refresh our memories, and then moving on from here to chapter 8, we'll look at the maintenance aspects with respect to computer networks, especially in preventive maintenance. Now, for those of you whose lockdown have been lifted, I say that you are welcome. Now you have the chance to go about, get some data, and get a few things to be able to join the classes online. But as the president said, your doorstep becomes your front line, and therefore you need to be careful. You need to observe all the protocols with respect to the COVID-19 disease. We expect that as we fight the disease, or if we are able to fight the disease, we meet everybody alive, and therefore make sure you observe all the protocols. If you don't have anything to do in town, if it's not essential, please stay at home. And then let us commit our lives to the protection of the Lord, and all of us will be fine. Thank you. So today, we are looking at networking concepts. We are going to explain the components and types of computer networks. We are going to explain the purpose and characteristics of networking standards. We are going to explain the purpose and physical components of the computer network. And then we'll configure network connectivity between PCs. Now, computer network devices and components comprises of host devices. Now, host devices are any of these devices that are able to send and receive information on the network. An example is a computer and a printer, like we can see here. And then we have intermediary devices that are the devices that fall in between these host devices and then make services available to them. So intermediary devices exist between the host. An example of them are the switches and the routers and all that. And then we have the media that connects all these devices together. The media are the components which the message travels through. And we have different types of networking media. We have the copper media, we have the wireless media, and then we have the fiber optic media. Now, the major types of computer networks we have, uh, we can start from the personal area network, where you can say that you have a small network in your personal area, like the connection and synchronization of one's smartphone to his computer. And then when in an office or when in a working area, you have a lot of them coming together. And these personal area networks are also interconnecting other offices. We say that they grow into local area networks. And local area networks are networks that span over a small geographic area, that is within a personal area or within an office or in between offices, buildings, or in a whole campus environment or in a small geographic area. So we have these local area networks could either be a wireless local area network or a wired local area network. So the wired ones are the ones that use cables, and the wireless local area networks are the ones or the types of networks where components connect to each other through the wireless fidelity, that or Bluetooth or infrared. And whenever you find yourself in an environment where there's a Wi-Fi automatically you connect to an access point or a hotspot, and you become a member of the network. And that is an example of wireless LAN. And then these wireless LANs also can grow into metropolitan LANs or metropolitan area networks, where we see that it has to do with connections of smaller networks within a metropolis. Let us use an example of a bank. If you have a bank that is also an international bank, in the office of the bank, you have the manager's table, you have the teller's table, you have the accountant's table. All of them are able to perform small personal area networks around. But then, if you want to check somebody's information on a computer, sometimes you go to the teller, and then the teller will say that if it's only your balance you want to check, go to the personal banker. So you realize that the personal banker in a small personal area has a connection uh, also with the teller or with the manager. So when you are able to check your balance at the teller's end, you are able to check your balance at the manager's office, you are able to check your balance at the personal accountant, the personal uh, bankers, or the relationship managers area. What it means is that at the table of the personal banker, there's a personal area network that can go on. And then at the teller's end, the teller can also perform a personal area network. But when the teller's office has a connection with the manager's office, we say that there is a local area network, because personal areas are interconnecting each other to become a local area network. Now, when all the computers are connecting each other in the bank, we say that there's a local area network. Now, you move from the one branch, like you are in Koforidia, you move from here, and then you go to Who. The same setting in Koforidia is also happening in the Who branch. But when you move from here to Who, you can also withdraw your money at the whole branch. That means that the whole branch also has a connection with the Koforidia branch. And within the individual branches at individual metropolitan areas, within them, you have local area networks and then personal area networks. So when a bank or when an entity is able to connect to another entity in a metropolis through the computer networks, we call it um, um, we call them metropolitan networks. Now, this same bank is an international bank. The whole of Ghana, all the regions that have the banks interconnect each other. Now, you move from Ghana and then you find yourself in the UK or London, and then you are able to withdraw your money there as well. Now, this is moving beyond metropolitan areas, and now countries are connecting to countries on the same computer network, and we call it wide area network. So a wide area network is a network that spans a larger geographic area, that is in between countries, continents and all that. Now we have other types of networks we call the peer-to-peer network. Now this kind of network connection happens between just two users. Now their sets or their devices that are able to connect to each other are their devices that are able to connect to each other as to be able to synchronize information are mostly only two. Now, this type of network has no centralized administration, and each computer decides which resource to share. So one is not uh, a boss over the other. Anybody can share any information at any point in time. So at one point in time, when the sender or whoever is sharing becomes the server, and whoever is receiving becomes the client. And the table can turn for the other side to also be sending. For example, you have a computer that has a Bluetooth connection with another computer, or you have a smartphone that has a Bluetooth connection with another smartphone to share resources. It could also be other types of uh, sharing applications like WhatsApp or like Zenda and any other type of sharing application. Now, what happens is that any person who is sharing does not have too much control or does not have the control over that network because everybody decides what to share and what to receive. But the client server networks does not happen that way. The client server networks are designed to have uh, a server software installed on the client for access. So the server controls the network and the server decides what to share to the client. So the server shares and the clients receive. And therefore, resources are controlled by a centralized administrator where the administrator decides who to share the information to and who to receive the information, as opposed to the peer-to-peer connection. Now we talk about standards. Now, networking standards are specifications that are documented for manufacturers to follow in the manufacture of networking equipment. So in Ghana, we have bodies that maintain certain standards. Now we have the Ghana Standards Board that maintains standards with respect to specific uh, operations. Uh, if it's for fuel, Standards Authority will make sure that the fuel is of a particular quality, and anybody who has to produce a fuel or produce petroleum products will have to follow a particular principle to obtain the required specification and standard. And it happens to almost every area of the economy and e-commerce where standards will have to be followed. Now, in data communications and networking, you have organizations such as the Institute of Electronic and Electrical Engineers, IEEE. We have the Internet Engineering Task Force and the International Standards Organization. Now, they develop open standards for networks so that clients running any operating system can access the network resource. Now, the OSI model and the TCP/IP model, which was propounded by the ISO, are both reference models used to describe data communication. So when you take the OSI model, right, this OSI model is a model or a theoretical model that seeks to explain what happens in a data transmission medium and the protocols and relationships in the layer, and then the devices that can be found at every layer in the source and destination communication of a network. So it seeks to help one understand and isolate problems at every level within the network transmission. But you realize that the TCP/IP model is also a four-layered model as opposed to the seven-layered model. Now, this four-layered model also inculcates all the other layers of the OSI model into it. You see that the application layer here comprises of the application presentation and the session layer in one, which is called application here. And then the transport layer is also the same transport layer. The network layer commensurates the internet layer for the TCP/IP model. And then the network access layer comprises the physical and the data link layer of the OSI model. Simply, the OSI model uh, is a theoretical explanation of data communication procedures. And then the TCP/IP model is the working model That happens on the ground. So when you pick your computer and you want to have a communication, you realize that you have to go into the TCP/IP settings and put an IP address. You put the subnet mask, default gateway, and all these other things. That is what we say that is the working model that is on the ground, right? But in all the process, it contains the explanation of these 7 layers. So when you pick the application layer of the TCP/IP model, you are sure to find the presentation and the sessions layer and their protocols. And every device that operates in all these 3 areas can be found in just this area. And then as application data is passed down through the layers, protocol information are added to each level. And this is known as encapsulation. Data encapsulation means the wrapping of data and adding necessary information for it. Now, when we take the OSI model, the OSI model can be explained through uh, the use of the postal system. Now, in the postal system, what you do is you express your thoughts on a letter, which we say that, which can be likened to the physical layer. Now, this letter you have expressed your thoughts or the expression of thoughts. This letter, before you send it to the post, you put it in an envelope. Now, when you put it in an envelope, you put the sender's and the recipient's address on this letter. Now, as soon as you put that letter in an envelope, that letter has been wrapped, and we say that it has been encapsulated. And then information that will be needed to be sent to the user is the source and destination address. So now, as soon as it is encapsulated and all these addresses are put on it, it moves to the second layer, which we call the data link layer. Now, this data link layer, the letter is also sent to the post office. Now, why is the letter going? Is it going to Kumasi? Is it going to Accra? Is it going to Tamale or whatever? So now at this point, the letter moves to the network layer. Now, if it is going to Kumasi, okay, now we are going to put it in another envelope. Put all the letters that are going to Kumasi in one envelope. And then we look for the Kumasi vehicle to be standby so that so when we wrap all these letters and we said we label them with the information that they are all going to Kumasi, that means that we have moved to the network layer, which is layer 3. And at the network layer, you can find routers, and routers select the best path, flow control, and error correction. So the routers will determine where the letters are going and send them. So if it determines where the letters are going, it is going to do the transportation. That means that information has also been added to those envelopes, and then the car has the network layer or the has known where the information is moving, and then the router begins to transport the information. So at the post, you realize the Kumasi car will begin to send Kumasi letters and all that until the letter is represented to the person, and the person picks the letter and reads it. As soon as he reads it, it is at the application level, and if he has to reply, the process starts again. And when he replies the letter with another letter, he expresses his thought. That will be the reply. It starts at the physical layer, and he also puts it in an envelope, goes to the data link layer, and that is what happens. So this is known as encapsulation. So anytime it moves from one level to the other in electronic communication, information is added, it is wrapped, it is until it reaches the user. We say that there has been an encapsulation. Now we have an Ethernet protocol, and Ethernet is a local area network protocol. Protocol is simply a set of rules. So when we take a LAN, the arrangement of the LAN or the components of the LAN, all the devices that can be found in the LAN, all the cables that can be found in the LAN, and then all the protocols that the components also use to transfer data from one component to the other is defined, or it's called Ethernet. So Ethernet is a LAN protocol which defines, explains, and then seeks to give the rule on how lands are supposed to look like, the physical topology, the logical topologies. Now, this Ethernet operates a half duplex, and the Ethernet standard for a local area network protocol is called the IEE 802.3. Now, when we talk about IEE 802.3, it means that this body, IEE, supersedes Ethernet operations, but in a book called the Request for Comments, the 802.3 column contains information about Ethernet and its operation. So anybody who wants to, or any organization, any manufacturer who wants to, who has to manufacture a device that has to work in an Ethernet network, will have to follow the standard as specified in the request for comment. And when you do that, it brings about interoperability, it brings about interconnectivity, and it brings about vendor collaboration. What am I talking about? What I'm saying is that when standards are maintained, devices that are found in a particular area of the network will have to operate in the same way. So you can have a Lenovo laptop being able to communicate in a network that also contains a Cisco router, or that also contains a laptop that is also on a network that is coming from Acer. The reason is that all of them have followed standard with respect to the access points or the RJ45 ports. So all of them have followed the standard and they are using standard ports so that cables or wires or access points can be hooked up to at the same time, irrespective of vendor differences. So now, this protocol IEEE 802.3, which is called the Ethernet protocol, operates with another protocol called the Carrier Sense Multiple Access and Collision Detection. Now, this CSMA-CD protocol seeks to solve the issue of collisions on the network. So you realize that if you have a network of a shared medium like a bus topology, let us take this illustration as computers that are connecting on a network or a bus line using a common shared medium. That means that we assume that this shared key is a computer, WP is a computer, WEP is a computer, 802.1 WPA2 is also a computer. It's just an assumption for you to get an understanding. Now, it means that if WEP computer wants to send information to shared key computer, it will have to use this common medium. In the same way, all these ones will also use this same common medium. Now, in the event when any of them wants to send information from one host to the other, it has to read and listen. If the shared medium is free, then it can send it. But there can be instances where both computers can be sharing information. Both computers can be sharing information, or we will want to send information at the same time. So both two computers like WEP and A02.1 all want to send information using this shared medium. And when they all listen to the medium at the same time, it means that when both of them listen at the same time, they will all know that the medium is free. And when both of them send, if this one sends, this one here sends through here, and this one also sends through here at the same time, it means that the information or the data that is going through this shared medium is going to crash. And when they crash, we call it a collision. So when collision occurs, there's a network jam. We can also use the road as an example. When you have a common shared road, and cars that are going from opposite directions are moving. When there's an accident between two cars from the opposite direction, it means that the road will become jammed and the cars that are coming from opposite direction might not be able to move until the police comes in, come to measure, and then remove the cars from the way before there can be free flow of traffic. In the same way, in this electronic communication, this is what happens. So when there's a collision, the network is jammed. But Ethernet says that I have a protocol to solve issues of network collisions on a shared medium. Whenever there's a collision, the CSMA CD comes in and says that, okay, fine, collision has happened, but we want to clear the transmission medium to be free. In the clearing of the transmission medium, I'm going to make sure that I set timing for all of you who want to use the medium, so that both computers cannot listen at the same time and send at the same time. So when I set the delay timings, it means that when this one listens, anytime this one will listen, that the time will be different from the time this one will listen. The time will be different from the time this one will also listen. So that at every point in time, with the varieties in timing, they cannot all send at the same time to solve the issue of recurrent collisions on a shared medium. If you can, if you can, if you can hear me, if you can hear me, just type hi. If you can hear me, just type hi in the. If you can hear me, just type hi like I've typed hi. Very good. If you are following, just type hi in the chat area. Hans, good. I see hi from Aqua Stanley. I see hi from Rahina. Now I see hi from Eugene Dankwa. Good. That shows that uh, some of you are, are listening, and that is good. Right. Now, the 802.3 standard also specifies cable types for Ethernet, and then we have Ethernet standards, which we call the legacy Ethernet, the fast Ethernet, the gigabit Ethernet, and then a 10G based technology Ethernet. Now, what it means is that with the advent of Ethernet technology, the devices and the speed of operations were at 10 megabits per second transmission. The devices were transmitting at a baseband using a twisted pair. Now, as time went on and Ethernet uh, uh, were being congested, now the standard increased the magnitude by 10 and said that now we can have devices that will transmit at 100 million bits per second and then still using a baseband and then still using a twisted pair connection. And then it went on, and so the 10 base T, which is called the legacy Ethernet, the 100 base T is what we TX is what we call the fast Ethernet. The 1000 base T is what we call the gigabit Ethernet, and then the 10G base also is the latest one that has improved of the gigabit Ethernet. Uh, and then the 802.3 standard says that any LAN can operate in these standard Ethernet speeds. Now, the IEA 02.11 standard specifies wireless LANs to use carrier sense multiple access and collision avoidance. Now, this CSMACD, now the CSMACD, the CMAC, the CSMACD, the CSMACD is used with the wireless or the wired connection, but the CSMACA, which is the carrier sense multiple access with collision avoidance, is also used for wireless connections. Now, for the wired, that's why we use the bus topology. But for the wireless also use the shared medium, but the shared medium is the air. But the medium that is used is a particular um, spectrum where data information are also transmitted. In the same way, on a wired medium, there can be collisions. So on the wireless medium, when you are a member of a particular wireless LAN using a particular shared medium, there can also be collisions. And when collision happens, this CSMACA, using the same principle as the one for the wired, also takes care of the devices that are operating in the wireless LAN and sets timing for them so that there cannot be recurrent uh, collisions in a wireless medium. Now, can you see the screen? If you can, if the screen sharing is there, type yes. If you can see the slides, just type yes. Okay, okay. Thank you. Thank you. If the slides are there, that's fine. Okay. Now, for the wireless LAN, Ethernet wireless LAN, their standards are not 802.3, but their standards are 802.11. So the 802.11 wireless standard says that IEEE says that anybody who wants to manufacture or who wants to operate within the wireless standards in a computer network must follow these standards. Now, we have the 802.11a. They have their own frequency of operation. 802.11b, 802.11g, 802.11n, and 802.11ac. So within that, we can find the Bluetooth. Within that, we can find the infrared. Within that, we can find the wireless fidelity, which we call the Wi-Fi, and other microwave connections. And all these spectrums are what we call the unlicensed spectrum. That means that all those areas, frequencies, are used for free. Now, when we go to the licensed frequencies for wireless and microwave areas, that is when NCA comes in, so that the radio stations all have their frequencies which they pay for. The telecommunications also have their frequencies which they pay for. But for the wireless LAN, all these frequencies are unlicensed and are free. So you can just get up and put on your Bluetooth and then you share. You can just get up, create a hotspot for others to join, which we call the wireless LAN, and then you create a wireless LAN and you share, and nobody will charge you for it. That's why we call them unlicensed spectrum. So when configuring a wireless LAN, use the strongest encryption available. And then we have different types of encryption. And what is encryption? Encryption simply means that you're changing the format or coding a particular format to change a particular string of letters or legible string of letters to scrambled text and numbers so that somebody or an unauthorized person cannot quickly get it and understand it. So the wireless media is protected by shared key or wireless extensible protocol or wireless protected access and WPA2, and then the strongest one is the WPA2. So when you create a hotspot on your phone for somebody, that is where you put your password, WPA password, and it's encrypted. Now we look at physical components. Modems or modulators, demodulators convert computers' digital data into a format that can be transmitted on the ISP's network. Switches microsegment LANs by sending data only to the computer that needs it. We say that they microsegment LANs because any computer or any device or any end user device that connects to the switch has its own collision domain and its own broadcast domain in the same broadcast domain but on different collision domains. And therefore, a message that is intended for a particular port will go straight to that particular port. Unlike the hub network or unlike the hubs which do not microsegment, but any information that is sent to one port is duplicated in all other ports. And such area has all the hosts that are connecting to them are in the same collision domain and in the same broadcast domain. Now, the wireless access points also have a connection or connect wireless devices. Routers use IP addresses to forward traffic to other networks. Now, in a home or a small office, a route or a route often includes a switch, a firewall, and an AP. Now, look at this illustration down here. If we want to talk about a route or a route, it means a particular computer here sending information through the transmission medium. It gets to the router at layer 3, and the router determines where that information is going. And to be able to achieve that, you need a switch, you need a host, you need a firewall, and then you need a router to be able to achieve a complete route or a route. So you can have an access point, which is an integrated service router that also provides wireless access. So here, the internal network contains computers H2, H1, and a server. Now, if these hosts want to go to the outside network, they have to go through the switch. Now, from the switch, it has to go through a firewall to protect, or which protects the network of the internal network. Now, when the firewall is able to sieve and provide access to the outside of the network, then it gets into the router, and the router will determine, considering the information on the packets that it has received, will determine where it has to go. So if it has to go to an external network, if somebody is receiving information that is in the router sends it directly. Somebody's microphone is on, can the person just put it on? Okay. Now we want to talk about wireless media, and in talking about wireless media, we cannot forget about coaxial and twisted pair cables, which use electrical signals over copper to transmit data. Now, we know that copper medium, transmission on a copper medium has its own issues. Some of the issues with respect to the copper transmission has to do with segment length and signal attenuations. Now, segment length are the permissible distance of a cable to be able to transmit data signals over it. And when it gets to a particular point, that distance, the signal will fall, and we call it signal attenuation. So when that cable will still have to be able to send information, you need a particular device or a repeater to regenerate and retime the signal to the respective uh, segment length again. And when the process is repeated, it is repeated until it reaches their destination. Now, fiber optic cables also transmit data through it. But when data is being transmitted through it, the data is transmitted through the use of light rays. Now, it has a glass in it, and the glass receive the light rays. But fiber optic transmission do not have a problem with signal attenuations. We don't have specific distances for, for fiber optic cables where signal attenuation can occur. We know the speed of light, and the speed of light determines how data or how fast data and information can travel through a fiber optic cable. And these cables also differ in bandwidth, they differ in size, and they differ in cost. And you can bear with me that fiber optic cables, because their problems are not as varied or as much, and they are more durable, their cables are more expensive. Only that the fiber optic must have its special care, and it must not be susceptible to abrasion, where abrasion means that something must not hit on it, because if something hits on it hard, the glass will break, and if the glass breaks, the light that is carrying the data that is passing through the glass will either be refracted or reflected. And when the light refracts or reflects, it means that it will not have the chance to carry the data to its destination. And that is the only problem with fiber. Apart from that, it travels to whichever distance it has to go. That is why you can have fiber that is running through the sea from countries to countries to provide internet services and other network services. And then there are several types of coaxial cable. We have the 10 base 5, which we call the thick net, the 10 base 2, we call the thin net. And the differences are that the 10 base 5 is thicker and has a segment length that is higher, which is 500 meters before signal attenuation. And then the 10 base 2 also has a signal attenuation of 200 meters. The 10 base 5 and the 10 base 2 is also smaller in diameter, which are normally used for our television. And then the thicknet are normally used as backbones for wide satellite connectivities. And then we have what we call the cable TV, which are also used for the television. And then we also have the twisted pair cables, which also have their own color termination pinouts that could be used to either make and unmake certain types of cables. And for example, we have a twisted pair cable, which is either shielded or unshielded twisted pair, which can be used to terminate a crossover cable with a specific or specified pinout, and then which can also be used to make uh, a crossover cable, which also has its own pinout. And then the fiber optic cable, we have two types. We have the single mode fiber cable, which uses lasers to send a single ray of light that can travel hundreds of kilometers. And then we have the multi-mode fiber, which also uses light emitting diodes to send multiple light signals that can travel up to 550 meters. So the twisted pair is the most popular type we use, and it has a standard. Now, the Telecommunications Industry Alliance is a body that supersees how patch cables, for that matter, how twisted pair cables and their pinouts and their color combinations and pinouts are terminated. So the T568A pinout for one side, which is this one, when you combine the pinouts, which is white, orange, orange, white, green, blue, green, and white, brown, brown. When you do the same combination at both ends, you can have what we call the straight through cable. But when you do one combination at one end and then a cross combination which comes with white, green, green, white, orange, blue, orange, and white, brown, brown at the other end. So two separate combinations at two different ends. When you follow the pinouts strictly and you terminate them, you are going to have what we call the crossover cable. Now, the straight through cables are used to make connections to uh, unlike devices, like a switch to a hub, like a switch to a PC, like a hub to a PC, and all that. And then the crossover cable is also used for connections of like devices, like a PC to PC, like a router to a router, like a switch to switch, like a hub to hub, and all that. So these are the peanuts. Good. We look at basic networking concepts and we look at addressing, right? Network equipment addressing. Now we have what we call the media access control address. Now this address is normally an address that is hard coded. When we want to say it is hard coded, it means that it is permanently stored in a particular buffer or in a particular storage of the network interface card by the manufacturer. So when you go out and you buy a phone, or you go out and you buy a smart TV, you go out and you buy a laptop or a desktop, all of them come with an identity. So anytime they join a network, that identity is displayed to identify them. So the MAC address is a 48-bit long represented by a hexadecimal or in hexadecimal. Now, hexadecimal is base 16. We have the base 2, which is the binary. We have the decimal, which is base 10, and then hexadecimals in base 16. And I think that by now you should understand how to convert binaries to uh, decimals to hexadecimals, and to octals. Now, that should have been done uh, in your network mathematics courses, and we will not waste too much time on it. Now, the internal or the internet protocol address, which is the IP address, is assigned by a network administrator based on the location within the network. Now, before even we come to the IPs, you see that these are hexadecimal numbers. So the hexadecimal numbers can either be represented with dashes in between, or they can be represented with what we call semicolons in between. And then they can also be represented with periods or dots in between. So the IP addresses assigned by a network administrator is based on a location within the network. Now we have two versions of the IP addresses. We have the 32-bit long IP address, which we call the IP version 4. Why is it 32? It is 32 because it has 4 octets, and each octet has 8 binary digits. So when you multiply 8 by the 4 octets, you have 32 bits long. And then the IP version 6 is 128 bits long, which is represented by a hexadecimal. So an hexadecimal number starts from 1. When you reach 9, it moves to A, B, C, and D. So a combination of a number and a letter will show you the length of that particular address. Hello, Auntie. Morning, oh. My phone, no, but the tried into no, I'm in a cat. ne phone no wɔ ne nkyɛn ne phone no wɔ ne nkyɛn ayɛ na ne phone ɔwɔ na ne nkyɛn ne frɛ ɔbɛ nsa bɛka